They called it the Panzerschreck der kleinen Mannes, the tank terror of the little man. On the afternoon of August 9th, 1944, near the village of Mortain in Normandy, Sergeant William Hadley of the 2nd Armored Division watched from his Sherman tank as a German soldier stepped out from behind a stone farmhouse wall approximately 70 yards away. The German carried what looked like a metal tube on his shoulder. Hadley had seen bazookas before. This looked similar but larger, cruder somehow. The German took a moment to aim, bracing himself against the wall. Hadley shouted a warning to his driver. Before the Sherman could traverse its turret or move, the German fired. There was a flash, a whoosh of propellant, and then an explosion that rang through Hadley's tank like a bell. The Sherman shuddered. Smoke poured into the fighting compartment from somewhere behind the turret. Hadley ordered his crew out. They bailed through the hatches, hitting the ground and running for cover in the roadside ditch. Behind them, their tank burned. When they examined it later, after American infantry had cleared the area, Hadley found the impact point. A hole approximately 3 inches in diameter penetrated the rear hull armor where it was thinnest, about 1.5 inches thick. The edges of the hole were bent inward, melted and torn by the force of the shaped charge that had punched through. Inside the engine compartment, the penetrating jet had ignited fuel lines and set the engine ablaze. The tank was a total loss. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The weapon that destroyed Hadley's tank was a Panzerfaust, and by the summer of 1944, it had become the Wehrmacht's answer to a problem that had plagued German forces since the invasion of Normandy. German armor was superior in many ways to Allied tanks. The Panther and Tiger mounted more powerful guns and had thicker, better-sloped armor than the American Sherman or the British Churchill. But there were never enough of them. German tank production in 1944, even at its peak, could not match Allied output. American factories alone built over 17,000 Sherman tanks that year. Germany produced approximately 8,000 tanks of all types combined, and many of those were lighter vehicles like the Panzer IV. This left German infantry facing massed American and British armor with inadequate support from their own tanks. The standard German anti-tank gun, the Pak-40, was effective, but required a crew of 5 men, weighed over 3,000 pounds with its carriage, and was difficult to conceal or move quickly. German forces needed something an individual soldier could carry, something simple enough to mass produce, something cheap enough to distribute widely, and something powerful enough to destroy the heaviest Allied tanks. Panzerfaust was the solution. Its development began in 1942 at the Hugo Schneider AG factory in Leipzig, known by the abbreviation HUSAG. Engineer Heinrich Langweiler led the design team. The weapon they created was elegantly simple, almost primitive in its engineering, yet devastatingly effective in its purpose. It consisted of a disposable steel tube containing a propellant charge and a warhead mounted on a wooden tail boom. The warhead itself was the key innovation, a shaped charge using the Monroe effect, a principle of physics discovered in the 1880s but only weaponized effectively in the 1940s. When detonated, the shaped charge created a high-velocity jet of superplastic metal that could penetrate armor far thicker than the explosive charge alone could defeat. The Panzerfaust required no complex fire control system, no sophisticated aiming mechanism. The soldier simply removed a safety pin, raised the tube to his shoulder, aligned simple iron sights on the target, and pressed a trigger lever. The propellant launched the warhead toward the target at approximately 100 feet per second, slow by artillery standards, but sufficient for the short ranges at which the weapon was designed to operate. The first Panzerfaust models entered service in 1943 on the Eastern Front, where German troops used them against Soviet armor with considerable success. But production remained limited until the desperate circumstances of 1944 forced Germany to prioritize cheap, mass-producible weapons over sophisticated systems. By June of 1944, when Allied forces landed in Normandy, German factories were producing Panzerfausts at a rate exceeding 400,000 per month. The weapon came in several variants, each designated by its effective range in meters. The Panzerfaust 30 had a practical range of 30 meters, approximately 33 yards. The Panzerfaust 60 extended this to 60 meters. Later models, the Panzerfaust 100 and the Panzerfaust 150, offered even greater range, though the basic operating principle remained unchanged. All models used the same shaped charge technology, all were single-shot disposable weapons, and all could penetrate approximately 8 inches of armor plate at a 90-degree angle of impact. This penetration capability was the critical factor. The Sherman tank, the workhorse of American armored forces, had frontal hull armor measuring 2 inches thick at 56 degrees from vertical, providing effective protection equivalent to approximately 3 inches against anti-tank projectiles. The turret front was 3 inches thick. Side armor was 1.5 inches vertical. Rear armor was 1.5 inches or less. The Panzerfaust could defeat any of these armor thicknesses with ease at close range. German tactical doctrine emphasized this advantage. Infantry units received training in Panzerfaust employment as part of basic instruction. The weapon required minimal training. Soldiers could become proficient after firing just 1 or 2 practice rounds. Official German doctrine specified that Panzerfaust teams should engage tanks from concealed positions at ranges under 50 meters, aiming for the side or rear armor where penetration was guaranteed, and where hits were more likely to cause catastrophic damage to fuel, ammunition, or engine components. The psychological impact on German infantry was significant. Soldiers who had felt helpless against Allied armor now had a weapon that could destroy tanks. One Panzerfaust weighed approximately 11 pounds loaded, less than a third the weight of a standard infantry rifle and ammunition load. A single soldier could carry multiple Panzerfausts, and the weapon required no special strength or training to operate effectively. The shaped charge did not care about the size or strength of the man who fired it. It would penetrate armor with the same effectiveness whether fired by a veteran soldier or a hastily trained Volkssturm conscript. For American tankers arriving in Normandy in the summer of 1944, the Panzerfaust represented a new and terrifying threat. Tankers had trained to fight other tanks, to engage anti-tank guns at range, to suppress infantry with machine gun fire and high-explosive shells. They had not prepared for cheap disposable weapons that could be fired by any German soldier from windows, hedgerows, or basement ruins at ranges so close that the tank's main gun could not depress low enough to return fire. The terrain of Normandy made the problem worse. The region's distinctive bocage landscape consisted of small fields divided by ancient earthen banks topped with thick hedgerows, some dating back centuries. These hedgerows grew 8 to 12 feet tall, with root systems that penetrated deep into the earthen banks below. The hedgerows created natural defensive barriers that channeled armor into predictable routes, providing German infantry with countless ambush positions. American armor advancing through bocage country moved slowly, confined to narrow lanes between hedgerows or attempting to break through the hedgerows themselves, a process that exposed the thin belly armor as tanks climbed the earthen banks. German soldiers with Panzerfausts could hide in the hedgerows, wait until American tanks passed within effective range, and fire at the vulnerable side or rear armor. The hedgerows provided both concealment and cover, making it nearly impossible for American tankers to spot the threat before the Panzerfaust fired. After-action reports from American armored units in July and August of 1944 documented increasing Panzerfaust casualties. The 3rd Armored Division reported losing 23 Sherman tanks to Panzerfaust attacks in a single week of fighting near St. Lo. The 2nd Armored Division noted that Panzerfaust attacks accounted for nearly 40% of tank losses in bocage fighting, exceeding losses to German anti-tank guns and enemy armor combined. Individual tank companies reported that Panzerfaust attacks caused more crew casualties than any other German weapon, because the penetrating jet often ignited ammunition or fuel, leading to catastrophic fires that gave crews little time to escape. Tankers began to fear the Panzerfaust more than they feared German tanks or anti-tank guns. You could see an anti-tank gun's muzzle flash. You could maneuver against another tank. You could suppress machine gun positions with your own weapons. But the Panzerfaust gave almost no warning. A German soldier could step out from cover, fire, and disappear back into the hedgerows in seconds. The shaped charge warhead moved too slowly to create a visible tracer, and the minimal smoke signature from the propellant charge made the firing position difficult to locate. By the time American tankers realized they were under attack, the penetrator had already struck. The psychological strain was immense. Tankers described the constant tension of moving through bocage country, knowing that every hedgerow, every stone building, every pile of rubble could conceal a German soldier with a Panzerfaust. The knowledge that your armor, which was supposed to protect you, could be defeated by a weapon that cost the German war economy less than producing 50 rounds of 75mm tank ammunition created a sense of vulnerability that no amount of training could eliminate. Crews began improvising their own solutions. The official channels, requests for additional armor, for modified tanks, for better protection, moved slowly through military bureaucracy. Ordnance departments studied the problem, engineers drafted proposals, and production facilities considered modifications. But none of this helped the tankers fighting in Normandy in July and August of 1944. They needed protection immediately, and they would create it themselves using whatever materials were available. The most common field expedient was sandbags. Tankers requisitioned sandbags from engineer units, who used them for fortification construction. The bags, when filled with local soil or sand, weighed approximately 40 pounds each. Crews lashed them to their tanks using wire, rope, or spare track links. The placement varied by crew and by perceived threat. Some tankers focused on the front hull, adding a layer of sandbags across the glacis plate. Others concentrated on the sides, creating sandbag skirts that hung from the sponsons. Some crews covered the turret sides and rear, while others built sandbag barriers on the engine deck. The labor involved was considerable. A Sherman tank has approximately 400 square feet of vertical armor surface. Covering even half of that area with a single layer of sandbags required 50 to 70 bags, representing over 2,000 pounds of additional weight. Crews spent hours filling bags, hoisting them onto the tank, and securing them with whatever materials they could scavenge. The work was exhausting, done after long days of combat operations, often under artillery fire or in positions vulnerable to German counterattack. But crews believed the effort was worthwhile. The logic seemed sound. Panzerfaust warheads used shaped charges that required precise standoff distance to function optimally. The copper cone inside the warhead needed to form its penetrating jet at a specific distance from the target armor. If sandbags disrupted this standoff distance, if the warhead detonated prematurely against the sandbag barrier before reaching the steel armor beneath, the penetrating jet would dissipate before reaching the tank's actual armor. The sandbags would act as spaced armor, defeating the shaped charge through geometric disruption rather than through material resistance. This reasoning was partially correct in theory, but proved problematic in practice. Other crews pursued more ambitious modifications. Concrete became a popular choice for units stationed near towns or cities where cement was available. Tankers mixed concrete using cement, sand, gravel, and water, then poured it into wooden forms built around the tank's hull and turret. Some crews created concrete boxes on the front glacis, adding 3 to 4 inches of concrete protection over the existing armor. Others built concrete panels for the sides or added concrete to the turret sides and rear. The concrete modifications were even more labor-intensive than sandbags. Crews had to construct wooden forms, mix concrete in improvised containers, pour and level the mixture, and wait for it to cure. The additional weight was substantial. A concrete layer 3 inches thick covering 100 square feet of armor surface added approximately 3,000 pounds to the tank's weight. Some heavily modified Shermans carried an additional 4 to 5 tons of concrete, sandbags, spare track links, and other armor enhancements. Photographs from the period show Shermans festooned with these modifications. Some tanks looked like mobile fortresses, with sandbags stacked on every surface, spare track links welded to the hull in overlapping patterns, concrete boxes on the glacis, and logs or timber strapped to the sides. Crews painted names and slogans on their makeshift armor. The modifications became a point of pride, visible evidence that the crew was taking active measures to protect themselves rather than passively accepting the threat. Tank commanders reported that the modifications improved crew morale significantly. Men felt they were doing something, taking control of their survival, rather than simply hoping German infantry would miss or that friendly infantry would spot Panzerfaust teams before they could fire. The weight of sandbags and concrete, the hours spent applying these modifications, the visible bulk they added to the tank, all of this created a psychological sense of enhanced protection. The United States Army Ordnance Department viewed these field modifications with concern. Engineers at the Aberdeen Proving Ground in Maryland, the primary testing facility for American armored vehicles, conducted systematic tests to evaluate the effectiveness of field-expedient armor. The tests began in August of 1944 and continued through the fall, using captured German Panzerfausts and replica-shaped charge munitions fired at Sherman hulls, fitted with various protective measures. The test protocol was rigorous. Engineers mounted sandbags on Sherman armor plates in configurations matching those observed on tanks in Normandy. They varied the number of sandbag layers, the spacing from the underlying armor, and the density of the sand fill. They fired Panzerfaust warheads at these configurations from typical combat ranges, 30 to 60 meters, and measured the penetration results. The findings were unambiguous and troubling. Sandbags provided minimal protection against Panzerfaust warheads.
In most test firings, the shaped charge jet penetrated through the sandbags and through the underlying armor plate with nearly the same effectiveness as when fired at unprotected armor. The sand did absorb some of the jet's energy, but not enough to prevent penetration of the Sherman's standard armor thickness. When the warhead detonated against the outer layer of sandbags, the standoff distance was actually optimal for shaped charge function. The sandbags were far enough from the steel armor beneath to allow the jet to form fully before striking the metal. In a few test cases, sandbags actually worsened the penetration effect. When sandbag layers were compressed tightly against the armor, creating minimal air gap, the warhead sometimes detonated with its nose cone in contact with the sandbag material. This could disrupt jet formation slightly, but the sand particles themselves could be incorporated into the penetrating stream, actually enhancing the jet's abrasive effect on the armor. The test reports concluded that sandbags offered no significant protection against shaped charge attack. The weight penalty, 2,000 to 3,000 pounds for typical sandbag applications, reduced the tank's mobility, acceleration, and speed. The additional weight increased track wear, strained the suspension, and reduced operational range by increasing fuel consumption. Tanks modified with heavy sandbag loads experienced mechanical failures at higher rates than unmodified vehicles. Concrete modifications fared only slightly better in testing. Concrete has greater compressive strength than sand, and a solid concrete layer could potentially deflect or break up a shaped charge jet before it reached the underlying steel. But the testing revealed critical problems. Concrete cast in field conditions, mixed by hand without proper proportioning of cement, sand, and aggregate, often cured with inconsistent density and
strength, air pockets, inadequate mixing, or improper water ratios created weak points where the concrete would fracture under the explosive shock of a Panzerfaust detonation. More fundamentally, concrete added enormous weight. A 3-inch concrete layer covering the front glacis added approximately 2,000 pounds. Covering the sides and rear could add another 4,000 pounds. Shermans modified with comprehensive concrete armor carried total additional weight exceeding 6 tons, nearly 20% of the tank's base weight. This additional weight exceeded the design specifications for the suspension, tracks, and engine cooling system. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Field reports from units using concrete-modified tanks documented the problems. Engines overheated more frequently. Transmissions failed under the additional load. Tracks stretched and broke. Fuel consumption increased by 15 to 20%, reducing operational range. Mobility decreased noticeably. Tanks could not climb slopes they had previously managed, could not accelerate as quickly, could not maintain speed on rough terrain. In barrage fighting, where maneuverability was critical for survival, the reduced mobility made tanks more vulnerable to exactly the close-range Panzerfaust attacks the armor was meant to defeat. In September of 1944, the Ordnance Department issued technical bulletins discouraging field armor modifications. The bulletins cited the test results from Aberdeen, explaining that sandbags and concrete provided minimal protection while creating significant operational penalties. The bulletins recommended that crews remove unauthorized armor and return their tanks to standard configuration. Tank commanders were instructed to rely on combined arms tactics, close coordination with infantry, use of artillery and air support to suppress German positions, and proper tactical movement rather than passive armor protection. The response from combat units was mixed. Some crews, after reading the technical bulletins and understanding the test results, removed their sandbag and concrete modifications. They accepted the engineering analysis and recognized that the mobility penalties outweighed the minimal protection gained. Other crews refused. They had seen Panzerfausts penetrate unmodified Shermans. They had watched tanks burn. They believed their modifications provided at least some protection, and even a small improvement was worth the effort and weight penalty. This created a divide between official doctrine and field practice. Ordnance officers attempted to enforce removal of unauthorized armor, arguing that the modifications violated technical specifications and warranty provisions. Tank crews argued that they were the ones facing Panzerfausts, that they had the right to take measures they believed enhanced their survival, and that bureaucratic concerns about warranty provisions were absurd when men were dying. Some unit commanders sided with their crews, quietly ignoring the technical bulletins and allowing armor modifications to continue. Others enforced the removal orders, sometimes leading to bitter confrontations between tankers who felt their survival was being compromised by distant engineers who had never faced combat, and officers who felt responsible for maintaining combat effectiveness through proper equipment maintenance. The controversy revealed a fundamental tension in military operations. Soldiers facing immediate threats will adopt measures that provide psychological comfort even when those measures have minimal practical effect. The perception of enhanced safety, even if illusory, can improve morale and combat performance. But military effectiveness requires that equipment operate within design specifications, that tactical doctrine be based on verified capabilities rather than hopeful assumptions, and that limited resources, weight capacity, fuel, transport space, be allocated to modifications that actually work rather than to measures that feel protective but provide no real benefit. The truth about field armor modifications emerged gradually through the fall and winter of 1944 as American forces pushed beyond Normandy into Belgium and eastern France. The fighting continued, Panzerfaust attacks continued, and the debate about protective measures continued in tank crews across the European theater. What became clear through accumulated combat experience was more nuanced than either the Ordnance Department's categorical dismissal or the tankers' hopeful belief in sandbag protection. Field modifications did occasionally prevent penetration, but not through the mechanism crews assumed. When a Panzerfaust warhead struck sandbags at a severe angle, the warhead sometimes deflected or tumbled before detonating, disrupting the shaped charge jet formation. When concrete layers fractured under explosive shock, the fracturing could occasionally deflect the penetrating jet at angles that prevented full armor penetration. But these effects were unpredictable, dependent on specific impact angles and conditions that could not be controlled in combat. More importantly, crews discovered that the real protection against Panzerfausts came not from passive armor, but from tactical adaptation. Infantry learned to clear buildings and hedgerows more thoroughly before tanks advanced. Tank commanders learned to coordinate with infantry more closely, using infantry squads to suppress German positions at ranges where Panzerfausts could not effectively engage. Artillery and mortar teams learned to provide suppressive fire on suspected German positions as tanks moved through danger areas. Tanks themselves were modified, but with changes that actually improved effectiveness. Engineers developed hedgerow cutters, steel prongs welded to the front of Sherman hulls that allowed tanks to punch through Norman hedgerows without climbing the earthen banks and exposing vulnerable belly armor. These cutters, invented by Sergeant Curtis Cullen of the 2nd Armored Division and refined by ordnance engineers, were fabricated from German beach obstacles and welded onto hundreds of Shermans. The modification added minimal weight, improved tactical mobility, and reduced exposure to Panzerfaust attack by allowing tanks to avoid predictable routes. Tank infantry coordination improved through hard-won experience. American doctrine evolved to emphasize combined arms operations at the smallest unit level. Tank platoons operated with assigned infantry squads riding on the tanks or moving alongside them. The infantry cleared positions before tanks advanced into close-range engagement zones. Tanks provided suppressive fire to protect infantry as they moved. This tactical integration, rather than additional armor, provided the most effective defense against Panzerfaust teams. By December of 1944, when American forces faced German counteroffensives in the Ardennes, The sandbag and concrete modifications had largely disappeared from frontline units. Crews had learned through experience what the Ordnance Department's testing had demonstrated. The weight penalty outweighed any protective benefit. Shermans went into the Battle of the Bulge in standard configuration, relying on tactical skill, combined arms coordination, and superior numbers rather than improvised armor. The Panzerfaust remained lethal throughout the war. German factories produced over 6 million Panzerfausts between 1943 and 1945, an astonishing number that reflected both the weapon's simplicity and Germany's desperate need for cheap anti-tank capability. Panzerfausts destroyed thousands of Allied tanks in the final year of the war. American after-action reports from the fighting in Germany in 1945 continued to list Panzerfaust attacks as a leading cause of tank losses. But American tactical adaptation reduced Panzerfaust effectiveness significantly. Tanks operating with proper infantry support, using terrain intelligently, and avoiding predictable routes suffered far fewer losses than tanks operating independently or using the aggressive but careless tactics that had characterized some early operations in Normandy. The weapon remained dangerous, but it was no longer the existential threat it had seemed in the summer of 1944. The story of field armor modifications reveals something profound about how soldiers respond to threat, about the relationship between psychological comfort and practical effectiveness, and about the difficulty of accepting unwelcome truths when survival feels at stake. Tank crews facing Panzerfausts needed to feel they had some control over their fate. Passive acceptance of vulnerability was psychologically intolerable. The act of welding sandbags to armor, of mixing and pouring concrete, of spending hours modifying their tanks, this provided a sense of agency, a feeling that they were actively improving their chances of survival. The fact that these modifications were largely ineffective did not diminish the psychological need they fulfilled. Soldiers throughout history have adopted protective talismans, rituals, and practices that provide comfort without providing actual protection. Lucky coins, prayer routine, specific articles of clothing worn into combat, these serve psychological functions even when they have no material effect on survival probability. The sandbags and concrete served similar functions. They were security blankets constructed from available materials, physical manifestations of the human need to believe that effort and will can overcome material threats. The Ordnance Department's response, while technically correct, failed to account for this psychological dimension. Engineers and technical officers approached the question purely from a performance optimization standpoint. Additional weight reduced mobility. Testing showed minimal protective benefit. Therefore, the modification should be removed. This analysis was accurate but incomplete. It did not address the crew morale factor, the importance of perceived agency, or the reality that soldiers facing death will adopt measures that provide psychological comfort regardless of official technical bulletins. The most effective commanders recognized this and found middle approaches. Some allowed minimal modifications, a single layer of sandbags on the most vulnerable areas, spare track links welded to frontal armor, that provided negligible protection but significant morale benefit without imposing crippling weight penalties. Others focused on explaining the test results to their crews in detail, treating the tankers as intelligent professionals capable of understanding engineering analysis rather than as children who needed to be ordered to comply. What emerged from this complex interaction between threat, response, official policy, and field adaptation was a more sophisticated understanding of armored warfare. Protection came not from passive armor alone, but from integrated systems, armor combined with mobility, tactical coordination, fire support, and intelligent terrain use. The Sherman tank was not invulnerable, but it was adequate when employed properly as part of a combined arms team. German Panzerfausts were dangerous, but they could be defeated through tactics rather than through additional steel or concrete.
This understanding represented a maturation of American armored doctrine. Early in the Normandy campaign, some commanders had believed that armor should operate independently, that tanks were breakthrough weapons that could achieve success through speed and firepower alone. The Panzerfaust, among other German weapons, demonstrated the fallacy of this approach. Tanks needed infantry. Infantry needed tanks, artillery, air support, engineering assets, and logistical support all had to function as an integrated system. No single component could succeed alone. After the war ended in May of 1945, military historians and analysts examined the armor modification controversy as part of broader studies on combat effectiveness and soldier adaptation. The studies concluded that the field modifications had been understandable responses to genuine threats, but had been based on incorrect assumptions about shaped charge defeat mechanisms. The studies also concluded that the Ordnance Department's technical bulletins, while factually accurate, had been poorly communicated and had failed to provide crews with viable alternatives to the protective measures they were being asked to abandon. Lessons learned from the controversy influenced post-war tank design. Engineers recognized that crew confidence in their vehicle's protection was almost as important as actual protective capability. Future tank designs incorporated features that addressed both practical and psychological needs. Armor configured to provide visible bulk that crews could see and trust, even when the actual protective value came from material properties and angles rather than from thickness alone. The Panzerfaust itself influenced anti-tank weapon development worldwide. Every major military force recognized the value of cheap, man-portable anti-tank weapons that could be distributed widely to infantry. The Soviet RPG series, the American M72 Law, and dozens of other post-war anti-tank rockets traced their conceptual lineage directly to the Panzerfaust. The shaped charge principle that made the Panzerfaust effective became the foundation for modern anti-tank weapons that can defeat armor many times thicker than the Panzerfaust could penetrate. For the men who fought in Shermans, who faced Panzerfausts, and who wrestled with the question of how to protect themselves, the experience remained vivid decades after the war ended. Veterans interviewed years later remembered the fear that came with every advance through built-up areas or dense terrain. They remembered the hours spent applying sandbags and concrete. They remembered the debates about whether the modifications actually worked. And they remembered the gradual realization that their survival depended less on passive protection than on teamwork, training, and tactical intelligence. Sergeant William Hadley, whose tank was destroyed by a Panzerfaust near Mortain in August of 1944, survived the war and returned home to Illinois. In an interview conducted in 1992, he reflected on his experience. "We thought the sandbags would save us. We really believed it. When they told us the testing showed it didn't work, we didn't want to believe it. But after a while, you learned that staying alive meant working with the infantry, meant not putting yourself in positions where some German kid could walk up and put a round through your side armor. The sandbags made us feel better, but they didn't keep us alive. Tactics kept us alive." That realization, that survival came from adaptation, coordination, and tactical intelligence rather than from additional armor, represented the central truth that emerged from the Panzerfaust crisis. It was a truth purchased through combat experience, through destroyed tanks and lost crews, through the gradual accumulation of knowledge about what worked and what merely felt like it should work. The sandbags and concrete that American tankers welded to their Shermans in the summer and fall of 1944 were not entirely useless. They served a purpose, just not the purpose their builders intended. They provided psychological comfort during a period when crews felt vulnerable and helpless. They represented human agency asserting itself against material threat. They were tangible evidence that soldiers cared about survival and were willing to work to improve their chances. These are not negligible functions, even if the protective value was minimal.
But ultimately, the lesson was clear. In modern warfare, hope and effort cannot substitute for accurate understanding of how weapons work and how they can be defeated. The physics of shaped charge penetration did not care about crew morale or good intentions. The additional weight that reduced mobility was a real tactical penalty, and the true path to survival lay not in passive armor, but in active adaptation. Learning the enemy's tactics, developing effective counters, and integrating all available combat resources into coordinated systems that were greater than the sum of their parts. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.